Alright, good morning everyone, and welcome to another ePrime live stream. In 1 second to make sure it's started. Alright, good morning everyone, and welcome to another ePrime live stream. My name is Devon Struthers. I'm the Product Service and Support Coordinator for Psychology Software Tools, and I will be leading the live stream today. So, what we have today is a pretty special one. This is actually a preview of our newest version of EET. So we're going to release our ePrime extensions for Tobii, or EET as I like to call it, for ePrime 3.0. And today I'm going to demonstrate a little bit how that works. We do plan on releasing this soon, end of September at the very, very latest. So this is a very new and upcoming product for ePrime 3. For those of you who are used to ePrime 2.0, this is something that we've already had, and the implementation is going to look very similar if you have it in ePrime 2.0. So what I'm going to be demonstrating today is taking a very simple experiment like this, and I'm going to not only add some eye tracking components onto it, so allowing ePrime to use gaze data from Tobii eye trackers onto it, but I'm also going to be adding some AOI capability, or areas of interest. So I'm going to be defining specifically 2 areas of this screen as my areas of interest, and I'm going to have ePrime let me know in my gaze data file, which is a file that's created using ePrime extensions for Tobii, whenever the participant was looking at that and for how long they were looking at it. And that's all something that's going to happen in the gaze data file, so I can take a look at it later for data analysis. So first off, if you have ePrime extensions for Tobii 2.0, or if you're watching this after ePrime extensions for Tobii 3.0 came out, the sample that I'm going to end up making today is actually one that's included with the install. If you go to your documents, go to My Experiments, and for those of you using ePrime 3, if you go to 3.0, and then go to Samples, go to My Experiments, go to Tobii, there we go, and then go to Samples, and go to TET. The sample that I'm going to end up making today for you guys is going to be TET Fixed Position AOI, and at the end we're even going to add some markers as well. So we're going to be sending some information to Tobii Pro Studio. For those of you who are using an eye tracker that's compatible with Tobii Pro Studio, this latter half of the webinar will work for you. Tobii also has a newer studio version. It's called Tobii Pro Lab. We are currently not compatible with Tobii Pro Lab at this time, so the markers will only really work for Tobii Pro Studio. Alright, so now that I have my experiment, I'm going to open an eStudio. I'm just going to kind of walk through it really quickly just to show you guys exactly what it's going to be doing. So the first thing I have here is a welcome screen. It says, welcome to the experiment. Before we begin the experiment, it is necessary to calibrate the eye tracker. So I'm going to be adding some calibration calls to this experiment that don't necessarily have in the experiment yet, or aren't necessarily there. But I do want to add some instructions here just to make sure that the participants know that this is what they're going to be doing. And I just explained the basic calibration process a little bit. So you will be shown 5 dots, one at a time. When the dots appear, please look at the middle of each dot until the dot disappears. Standard eye tracking calibration. On the next screen, you will see a black box. When you can see your eyes as 2 white orbs in the black box, press any key to begin calibration. That's something called track status in Tobii, or in ePrime extensions for Tobii as well. If you're not used to it and it's kind of your first eye tracking experiment, it honestly looks a little creepy, but it's really cool because it shows you both of your eyes, and it also lets you know how well how well your eye tracker sees each of your eyes. So then, obviously, our calibration track status are going to come between welcome and directions is actually just the directions for the task. So in this experiment, you will see a name and hear a sound of an animal. You will then be shown 2 pictures of animals. Press 1 key if the animal on the left made the sound. Press the 2 key if the animal on the right made the sound. So it's just going to be a very simple kind of lexical decision sort of task with a little bit of priming in there as far as the animal sound's concerned. If we were to have a hypothesis attached to this experiment, it would be that if maybe if the animal on the left made the sound, then participants will be more likely to look at that one first and therefore fixate on that one longer. Especially once we're adding eye tracking into that. That's probably what I would hypothesize for something like this. So we'll take a look at our trial list here. You can see we have quite a lot of combinations here. As far as experiment structure is concerned, we just made sure to hit all of the possible combinations. So we have our prime as either dog, cat, cow, or horse. And then left image as either dog, cat, cow, or horse, and same with the right image. and then we have what our correct answer is in here. This is just a sample that comes along with it. If for whatever reason you want to kind of have this as a nested list, we would recommend that as well, just to kind of nest all of those and get those looking pretty nice in this list object. But for now, it's only running 3 samples, and this is going to be a very functional list object for us. So I'm close out of that. The first thing I have is a fixation. Right now, it is just a fixation text display object. If you look at the duration, it's actually set to 0, and the pre-release is set to same as duration. I'm going to set this to 500 milliseconds for now, but what we're eventually going to do is we're going to turn this fixation point into a gaze contingent fixation. And instead of having this on the screen for 500 milliseconds and moving on regardless of whether or not participants have looked at it, I want to actually change this so participants have to stare at the fixation object, and E' will log that they've stared at the fixation object for 500 milliseconds before moving on. And that edit's going to happen once I start adding the eye tracking components, obviously, but it's a very easy edit, and I'll show you guys that. Now that I have my fixation, I'm going to have my prime. My prime will, of course, either be dog, cat, cow, or horse, and then the sound is going to be that sound file associated with it, and it is actually here in this prime. So if you look at my image here, or my sound here, I have resources / prime.wave, and if we look in my folder here, I have resources, and prime is cat, cow, dog, or horse. So it looks like both of those are going to work out just nicely for us. Then our stimulus here is going to consist of 2 images with a fixation in the middle. It is going to be left image and right image are our 2 attributes that we're referencing here. If we look in trial list, it's either going to be dog, cat, cow, or horse, obviously, and one of the 2, either left or right, is going to be the prime image, or the same as the prime image. These in our gaze data file are going to be our 2 areas of interest, and I even have them named appropriately. While not necessary, it's just going to help me keep things much clearer whenever I take a look at my data later. And this is going to be labeled as AOI1, and this one's going to be labeled as AOI2. So we'll be taking a look at both of these whenever we open up our gaze data file, just to see how long participants have fixated on either one of these. Then, of course, there's going to be a little feedback at the end, nothing too incredibly necessary, but it's always nice to have a little feedback on something like this. We'll just have correct and incorrect based on participants' response to stimulus. Take a look at the input object name. It is, in fact, stimulus. And then just a very simple goodbye text display object. I add those to all my experiments. I just think it's nice. All right, so if we're going to be adding eye tracking capability into this, the first thing we need to do is tell E', hey, we're going to be adding eye tracking capability into this experiment. So to do that, go ahead and double click on the experiment object at the top of the Experiment Explorer here. And then go ahead and take a look at the Packages tab. Now, when you install E' extensions for Tobii, it installs something called a package. And the package is E' extensions for Tobii. What this is essentially pre-written chunks of script that our developers have cleverly come up with that allow you to integrate with the eye tracker without needing to make this script from scratch or copy it from the source every single time. Now, to locate that, all you do is click Add, and then it's going to show you all of the packages currently available on your experiment. The 2 that I have are TET and Clearview. Both of those get installed with Tobii, or E' extensions for Tobii. The one we're going to focus on for now is just that TET. TET stands for Tobii Eye Tracker. I also have Timing Test and Registry. Those 2 are actually ones that I use internally for testing. Don't expect to see these on your particular computer whenever you run this. If you installed the E' extension for Tobii correctly, the only ones you should see are TET and Clearview. So go ahead and add TET to my experiment there. Go ahead and check the version. The version is going to be a little different since I'm using kind of a preview build, but otherwise this looks good. I'm going to go ahead and click Apply. So now E' knows, hey, I'm now looking at eye tracking data, or not eye tracking, eye tracking script. So now I can reference this at any point in my experiment. Now, one common thing that does happen sometimes is if you go ahead and click Add, and you know you've installed E' extensions for Tobii already, but you just can't see it here when you click Add. There's actually really an easy way to get around this. I'm going to go ahead and click Cancel out of here. If I go to Tools and then Options and then click on Packages, right now it's going to tell me exactly where on my computer it's looking for these packages. So right now it's looking at C, Users, Admin, which is the name of the account that I'm on, Documents, My Experiments 3.0 Packages. So if I go there, go to my C drive, Users, Admin, Documents, My Experiments 3.0 packages, you'll see that there's the packages there, and then by default, and this is something, those are the two packages that you saw there, and then by default, ePrime also checks this location as well. Go to Program Files, go to PST. It also looks in here for any packages, and you can see here ePrime extensions for Tobii Pro 3.0, packages, and then it actually has all of the package files that I'm going to be using here, but specifically it's looking at this tet.epk3 file. If you find that you can't see your package or that ePrime's not looking for your package, all you have to do is just go to that file location, make sure that that EPK3 is there, click on this Add button, and then specifically map ePrime to there. So go to this PC, and then go to Documents, and then go to My Experiments 3.0 and Packages if it lives there. Otherwise, you're going to want to go to just your C drive and go to that path that I showed you there. So either way will work, but this is a good troubleshooting step if you haven't, if you can't see your packages in ePrime. And then once the full path of the package files can be found there, go ahead and click Apply and OK. And then we recommend just restarting eStudio, so closing it down, or saving it, closing it down, and then opening it again. You should see that package file listed there under Packages, and click Add. You should see it listed there with no problem after the restart of eStudio. Alright, so now that I have my ePrime extensions for Tobii packages added, so now ePrime can see all of the script that we've made for ePrime extensions for Tobii, we need to actually point it at our eye tracker. So to do that, I'm going to click on Device, I'm going to click Add, and I'm going to select Tobii Eye Tracker because that's what I'm going to be adding to my experiment. You'll also notice that there's a clear view device there. We're going to be discussing that a little later, but for now we're just going to talk about Tobii Eye Tracker in the actual device itself. So, the Tobii Eye Tracker that I have today, if you look here, is the X3-120 model. Looks a little bit like this. It attaches just with a USB here, USB to USB-C, and if you're using an X3-120 model, whoops, sorry about that. Sorry about that, knocked my mic off. If you're using an X3-120 model like that, we definitely recommend, or even an X260 if you're using that model as well, we recommend using this thing. This thing is called an EPU. It is sold along with these X3-120 models, but what it does is it actually adds a little bit more functionality to the eye tracker and makes it more stable when working with ePrime extensions for Tobii. So now that I've added my eye tracker device, I'm going to have to add information from the actual hardware itself. So if I go to my eye tracker, the main property that I need to change here is the IP address / name. Now the IP address / name, if you're using the EPU like I am, can be found on the underside here. And I'm not necessarily going to type it in correctly, just to make sure, but it'll look something like this. And then there we go. And there'll be some letters too. Or X, whatever. There'll be some numbers and letters. It's a number-letter combination. But what we're entering here is instead of entering the IP address, we're actually entering the serial number of the Tobii Eye Tracker, or in this case of the EPU itself, that can be found on the back. Now the reason that we're entering this instead of the IP address is whenever you install ePrime extensions for Tobii, it installs another program called Bonjour. Now what Bonjour does is it takes the serial number of the Tobii Eye Tracker, or of the EPU in this case, and it turns it into an IP address. So this way you don't have to check your IP address of your eye tracker every single time that you're doing this. We will have to check the IP address of something else later, and we will get to that. But for now, if you're just doing very simple Tobii communication, the only thing that you need is that serial number that's found at the bottom of the EPU or on the back of your eye tracker, depending on the model that you're using. Now the important thing to keep in mind though is once you've put in your serial number, like I have here, you need to do dot, local, and then dot. Now that extra dot at the end is something that's actually really easily forgotten. It's something that is pretty easy to overlook, especially if you're doing this for the very first time. But that extra dot at the end is very important because it's how Bonjour uses, or how Bonjour recognizes that serial number as an IP address. If you just do .local, you're going to get an unable to connect error message in Tobii Studio. And it's going to say, hey, I don't know what this is. And this is actually one of the most common problems we find when working with ePrime and ePrime extensions for Tobii in particular. So it's important to always keep that dot at the end. Now the port number, under most circumstances, is going to remain at its default. That's completely fine. If you want to make a log file, you would just enter the name that you want the log file to the name of the log file that you want to be output right here. The log file just lets you know about the status of the eye tracker itself. And then another important property here is this sync mode property. Now, sync mode lets you know whose clock this eye tracker is going to listen to. By default, we have it set to local, which means that the Tobii clock, or the clock on little EPU here, is actually going to be listening and syncing itself to E prime's clock. So it's going to use E prime's timing, which is preferred because Tobii, while it does maintain very excellent timing, doesn't guarantee millisecond accuracy in the same way that E prime does. So we generally recommend keeping sync mode set to local, so the clock in the eye tracker is synced with E prime's time. However, if you want to have it the other way, you can do server, and that way E prime's timestamp or E prime's internal clock is going to sync with the Tobii clock. Or you can have it set to none, and E prime's clock is going to run independently of Tobii's clock, and you get both timestamps from each. Generally speaking, we recommend local. The next property here is max count. Now, max count is important because this is going to say, or let you know, after how many samples E prime is going to sit there, or E prime is going to spit out to the gaze data file before it begins to overwrite it. So right now, I have, after 4,096 samples, E prime will begin overwriting the gaze data file. Now that's a lot of samples, and that should be more than enough for this experiment, especially considering it's not a very long one. But if you have a particularly long experiment, we do recommend beefing this number up a little bit. This is the max, so this is going to get you 100 and, or no, this is going to get you, yeah, this will get you 1,048,576 samples before it overwrites it in the gaze data file. Generally speaking, experiments aren't that big, and when I say sample, I just mean basically a snapshot from the eye tracker. The way that these eye trackers collect data is they don't necessarily take videos. They take little snapshots at the same frequency as their refresh rate. So, for example, my eye tracker here, this is an X3120, which means that it works at 120 hertz, and that ends up being once every 8 milliseconds. The eye tracker basically takes a snapshot of your eyes and where your eyes are at that point. And this is telling me how many of those snapshots E prime is going to take before it begins to basically overflow the buffer and start backfilling them. And the display just lets you know, or it just allows you to set which display this eye tracker is going to be collecting data from. Since I only have one display on this computer, there's no need to touch that property at all. I'm going to go ahead and click OK. Now that I have all of my eye tracker information set up correctly. So the next thing I need to do is actually start adding the components of my eye tracking data to this experiment. I have E prime looking at my package call now, so it knows that there is this wealth of eye tracking information that it can get, but it's not getting it yet. And I have my device, so E prime knows, hey, there's eventually going to be a Tobii eye tracker connected to this computer. The next important thing is to actually start the eye tracker and get it eye tracking. So what we're going to do is we're going to add something called a package file object to the experiment. Package file objects are basically just callouts to other script that's written in .epk3 file. So basically I'm going to be referencing a very small chunk of the larger .epk3 file that I just added to my experiment. So in my toolbox here, I'm going to scroll down to that package call object, and I am going to put it just at the very beginning of my experiment. So I take a package call, I put it right here just before welcome, and I'm not going to rename it right now because I want to show you an important little warning that we give. But I'm going to double click on this package call one object, and I'm going to change the package to TET. So now E prime is looking in that TET.epk3 file, and it's going to show me all of the routines that I have available to me. And as you can see, I have quite a lot. The first one that I want to add right now is just open. And if you look, it's going to give you a little bit of an overview of what's happening as well as the parameters here. The parameters are important, albeit some of them are optional. So overview opens the TET device, which just means, hey, we're going to be eye tracking at this point in this experiment. Some of the parameters are C, context. Every single package call that we add has this. It's not necessary to change. I definitely recommend keeping it there. We have the state. This is an optional parameter for the requested state of TET communications, either on or off. If not specified, it will default to on, which makes a lot of sense. But in this case, I'll be testing my experiment. So what I'm going to do is I'm going to put a comma, and I'm just going to type the word off. And what this is going to do, now that I have a comma and the word off in quotes, is I'm actually going to be not eye tracking in my experiment. This is really good if you're kind of editing your experiment or building it without an eye tracker like I do, because I mean mine's kind of sitting on the table over here. It's not necessarily connected to anything, especially my computer. Another optional parameter here is to specify whether or not to immediately connect to the TET server. If not specified, it will default to true. Otherwise, you do a comma, type the word false, and then you can specify through a routine here exactly when, using this one here, the connect, you can specify exactly when we're connecting to the eye tracking server. Generally speaking, the defaults for all of these are all most people need. But in some instances, you might have some very specific eye tracking needs or very specific needs as far as server compatibility, so it's important to kind of keep that in mind whenever you add these. Now, if I go ahead and click Apply, I get this little package call eObject warning. It says the routine selected is not a substring of the name of the package call object. This is not an error, but we encourage you to name the package call object to reflect the routine chosen. So what that means is my package call object called package call1 isn't TET open. It's just called package call1, and if I click OK, you see a little icon change, but it's just called package call1. This isn't telling me anything about this, and if you've tuned in for some of my past live streams, you know that I'm pretty adamant about making sure that the name of an object reflects its function, and that's exactly what that error message says. So to make it happy, what I'm going to do is I'm going to rename it to TET open. And there we go. So now the TET open package call is added to the experiment. So now that I have it open, the next thing I want to do is I want to actually add that calibration. So if you take a look at my welcome screen here, it says before we begin the experiment, it's necessary to calibrate, blah, blah, blah. I want to add that to my experiment, and adding it isn't very difficult at all. What I do is hop back into my session proc, take another package call, and put it just after my welcome here. And I'm actually going to rename this one ahead of time because I know what it's going to be called. I'm just going to call it TET Calibrate. Now there are a couple of different different calibration routines when using ePrime. The one that I'm choosing here is regular. But if I go into my package call here, you'll see that I have a couple options. I have Calib Infant, Manual, and Regular. And Regular is exactly as my welcome screen described. It's going to be a red circle with a black dot in the center of it, and it's going to move to 9 different points around the screen. The circle will shrink to become roughly the size of the black dot, drawing your attention to the black dot itself. That's the point at which calibration is going to happen, and it's going to repeat that 9 times throughout the trial. And this is going to act in an automated fashion, so the fixation point is going to move around the screen completely independent of input from the actual participant. Manual, on the other hand, is actually, it puts a bit of a crosshairs on the screen with a little square in the middle of the crosshairs. And the way the Manual works is it allows the participant time to actually focus on that point between the crosshairs, and then whenever they are ready to move on, press the space button. And unlike Regular, which will manually move on without input from the participant, Manual will stay on a fixation point until input is detected on the space bar. And Infant is primarily for infants. This one is a much shorter calibration, but involves videos instead of either a ball moving around the screen or an actual just cross on the screen. To see the videos, and if you add the Infant, you can actually choose which videos are going to be loaded into that and which ones are going to be determined as distractor videos. So you'll have the participant or the infant look at the videos on the screen, and if for whatever reason their attention seems to wander from the very bright and flashy videos, and I'll show you those quickly because they're kind of funny. They're here in the resources, and one of them's a cat, one of them's a caterpillar, a dog, a bouncing ball, a duck, and they make nice little noises. So if I play duck, it's going to make a little. I'll just keep going with Windows Media Player. Oh, I do not want to set that up. I will not play this today then. But all it's going to do is just a little duck, and it'll make a little noise as it rattles around the screen. And then if for whatever reason the participant's gaze wanders, you can push the up or down arrow, and a new object or a new video will appear on the screen to kind of draw the infant's attention back. So it's definitely geared towards infants. But we're going to just click Calibrate here. And there isn't really anything that we need to set. We have the context, which doesn't need to change, handle pre-release, which honestly doesn't need to change either, and then clear calibration, which deletes all samples. We don't want to do that, so I'm just going to go ahead and click Apply and OK. Now, if you notice, since I called it TET Calibrate before I changed the parameter in there, or the routine in there, I didn't get that error message. So now in my experiment, E prime is going to know to calibrate right there. Now the next thing I want to do is I want to start logging some of my data. And in the way that EEPROM extensions for Tobii works is it actually makes a file called a gaze data file, which is literally of the file extension type gaze data. This can be read by Excel, and that's generally what we recommend reading it with, because it basically is just an XML file once it's all said and done. But we need to tell EEPROM that we're going to be actually writing this file. To do that, we'll need another package call. So we'll take a package call object from our toolbox here, add it to just after TET calibrate, and I'm going to rename this one to TET open gaze data file. A little long, but it's necessary. So we'll double click on that. The package for this one is of course going to be TET, and this one is going to be open gaze data file. And it says opens a tab delimited gaze data file, which means in the background EEPROM is going to make this object and it'll allow you to start writing data to it. If you want, you can actually just make it, you can change the file name if you want, but there is, by default, it'll just be experiment name, subject number, and session number, so it's going to look identical to your EDAT files if you want it that way. Generally speaking, the defaults for all of these are fine. There are some remarks at the bottom that are really important. So the first one here, if the file exists, data in the file will be destroyed. So if I'm ever overwriting a gaze data file, it's literally going to overwrite it. It'll take whatever values I have here, and it'll just overwrite it, and then says this function will use the next available file number, e.g. if this is the first file to be opened in the experiment, it may use file number 1, then usually will have to use file number 2 in their experiment. So we go ahead and click Apply and OK, because that's all I need for the TET gaze data file. And then once I have this, I want to actually, so I have open here, and I have open gaze data file. No, I want to close it. I want to tell EEPROM, okay, this is where I begin collecting gaze data. I want to tell it where to end collecting this gaze data. So this is just going to be another package call at the very end here. And then I'm going to rename this one to TET close gaze data file. Because what this is going to do is it's going to say, okay, my experiment's over. We don't need this extra file to be written to anymore. So my package will of course be EET. And this is just going to be close gaze data file. There's really nothing to change about this. The optional parameters are just handle pre-release of context. Going to keep them like that. Click Apply and OK. And then at the very end of our experiment, I'm going to add one just to tell EEPROM to disconnect from the eye tracker. And this is just going to be called TET close. Because once the experiment's over, I don't need to be eye tracking anymore, so I don't need to actually have it doing anything. So package will of course be TET. And my routine is going to be close. Generally speaking, on these close routines, there's really nothing to change about it. It's going to take whatever you've set in the open. So, you know, if we made a very special gaze data file name for TET open gaze data file, it's going to close whatever file you made. You don't need to specify anything else here. Let's go ahead and click Apply and OK, and it saves. So this is really the basics of eye tracking, really kind of the bare minimum that you need just to get an eye tracker even functioning and get a gaze data file written while you're running your experiment. Now, if you run this way and run with an eye tracker this way, you're really not going to notice any of the eye tracking components, and the gaze data file that you make is going to be completely blank. So let's start adding some more functionality to this just to make it a little more involved here. Now the first thing I want to do to make it more involved and to actually get some gaze data file or actually get some eye tracking components into the experiment and not just have this very basic structure here is I want to tell EEPROM where I need to start my tracking. So right now the Tobii Studio or the eye tracker is just kind of open and it's not necessarily tracking. I need to tell Tobii, hey, this is the important trial, I want you to start tracking right now. So that is, of course, going to be a package call on EEPROM. I'm going to take a package call and make the first object in my experimental procedure here. And I am going to rename this one just to TET start tracking. Double click on it to open it. And of course TET, and this one's just going to be called start tracking. So I have the option, the only option I have here actually besides C and handle pre-release is a clear history option, and if I want to I can kind of wipe out the history of my eye tracker device before I go ahead and start a new trial. Since it's a shorter experiment, I don't think this is entirely necessary, so I'm going to go ahead and click Apply and OK. because this is where I'll be starting tracking in my experiment. And conversely, I need to tell E prime where to stop tracking. I need to say, okay, at this point I don't necessarily need to see anything. I don't necessarily need to eye track anymore. One of the mistakes that a lot of first timers or a lot of new people to E prime extensions for Tobii make is they just say, oh, well, the entire experiment's important. I want to eye track during the entire thing. I'm just going to set start tracking at the beginning and stop tracking at the end because I want all of the gaze data. While that is nice to have sometimes, just know that you're going to make these then delays in your experiment whenever you go to write to your gaze data file. And the reason that you're going to make these delays is if you're eye tracking throughout your entire experiment, E prime has a lot of data to write to that external gaze data file, and it ends up kind of, delaying your experiment by a little bit while E prime does this. So it's important to take a look at only the most necessary components of your experiment and say, I'm only going to eye track there. So if I look at my experimental timeline here, fixation is important. I want that wait for fixation call. I want participants to fixate. That needs to be active eye tracking. Great. Prime, I want to see where participants were looking during prime. I want to make sure that they were focusing on the actual prime word there, because that might determine, how accurate they are in the next part of the task. So prime is important. Stimulus is where my two AOIs live. Obviously that one's important too. Feedback, not as important. I don't really care if they're looking at the feedback. It's nice to know that they're looking at feedback, but it's not entirely necessary. So I'm actually going to take my stop tracking call and I'm going to put it just after stimulus, because I don't necessarily need it on fixation. So I'm going to call this one TET stop tracking. I'm going to make the package called TET, and I'm just going to call this one stop tracking here. And again, like close data file, there really isn't anything for me to add as far as parameters are concerned or even mention, so I'm going to just click apply and OK. And there's my TET stop tracking. So now this fixation, prime, and stimulus, these are the objects that I'm most concerned about whenever I'm eye tracking in my experiment. Now, the next thing I'm going to do is I'm actually going to add something called a gaze replay. What this is going to do, and it's a lot for testing, but it is pretty cool and pretty showy to add to an experiment. What this is going to do is it's going to show participants exactly where they were looking on the screen whenever they were actually between this TET start tracking and TET stop tracking. And that's going to happen just after feedback. So look at the feedback on their accuracy, and then they're going to see, hey, this is where I was looking during this trial. And for first-time eye tracking, it's actually really cool to look at because it follows your gaze exactly. So I'm going to take a package call object and put it just after my feedback, and I'm going to rename this one to TET gaze replay, and hit enter. I'll change my package call to TET, of course, and I will change this one to gaze replay. Right there. Now, there are some parameters on here that aren't optional, and this is important. Some of the parameters in a lot of the other package files or package calls that I added were optional. I didn't necessarily need to change them. I could leave them blank and it's fine. This one does not need to be, or cannot be blank. So the TET gaze replay, the first one is the slide, and it's a slide object that will be drawn on screen before a replay begins. So what slide do I want them looking at when they watch this gaze replay? The most obvious one is going to be stimulus, so I'm just going to type the word stimulus. And then start time. This one's an optional parameter that creates a start timestamp for the first gaze point to be included in the replay. Typically, this is specified as the .onset time of an object in the experiment. If not specified, it will default to the first sample in the history, which is, of course, going to be my start tracking here. So if I keep it the way it is, what it's going to do is it's going to show participants fixation, prime, and stimulus, and where they were looking during each one of those three objects, all while stimulus was written on the screen. However, if I only want it to be the duration of stimulus, and I don't care where they were looking during fixation or prime, or don't care to show them where they were looking during fixation or prime, I can just type the word stimulus here, and it's just going to show me that. Or it's just going to show me the gaze that was written during that part. But I'm going to keep this the way it is. In stop time, that's if there's any point that I want it to stop. So let's say I have stimulus and 8 other objects after that. I don't want to show them the 8 other objects, just a stimulus. I would put that as my stop time. I'm going to go ahead and click apply and OK. And that's all I need for that gaze replay. And I'm going to go ahead and save this quickly just to make sure. It's always important to save things pretty frequently in E prime. And I will just say TET fixed position live stream. There we go. And then if you want, you can click on this generate button just to make sure everything is syntactically correct. So for example, if I go to TET gaze replay and I go to stimulus and in quotes I put something kind of silly, it'll end up giving me an error here. It'll say gaze replay type mismatch in parameter 2. So it's looking at this one that I put in quotation marks and it's saying, what is that? And this is a good way to troubleshoot if you've set up these package calls correctly. So I will just type stimulus. Now the reason that it is accepting just the word stimulus without quotes is because if you look here, it says slide in parentheses here. What that means is it's accepting something of a slide type. So stimulus is a slide object. The word stimulus refers to stimulus as the slide object. So this is actually going to compile now instead of my one in quotes. And there you go. So the next thing I want to add to my trial proc is I want to actually add that fixation. In EEPROM extensions for Tobii, it's just called a wait for fixation. And it actually does a lot of really cool things. I'm going to go ahead and add it to the experiment and then show you what it does. Make a package call and drag it just after my fixation object. And I'm going to call it TET wait for fixation. I'm going to add a TET package there, and then this is just going to be wait for fixation. Now I have, just as my overview, it says wait for the user to fixate on the designated object before continuing. When fixation is obtained, a key press will be simulated to terminate the input enabled on a specified slide. So the first one is context. That's always necessary there. Now here is the slide, which is important. It says a slide object in the experiment which will be used to obtain the fixation object and provide visual feedback if enabled. The slide object provided must have a sub-object declared upon it and named fixation. This is something that a lot of users kind of forget. So the slide can be named whatever it wants. I can call the slide object Devon is awesome, for example, and it's going to be completely fine as long as I put it right here. But what's important is that on that object, whatever it's called, as long as it's specified on here, there is a sub-object called fixation. That's specifically what we're going to be looking here. And it says the sub-object may either be a slide image or a slide text object. So we can't necessarily fixate on a slide movie using this package call. There are other ways to do that are far more complicated and really won't be discussed during this webinar or during this live stream, but just keep in mind that it should be a slide image or a slide text object. And it must have its border width property set to a value greater than 0 if you want visual feedback. So if you want the border of the fixation object to turn red or something like that, or turn whatever color I specify here very soon, the border color needs to be set to white, and the border width property needs to be set to something other than 0. So I'm going to put the word fixation here, since it represents the name of the slide object right here that my object is going to be on. Minimum fixation duration, I mentioned that I want it to be 500 milliseconds, so I'll put 500. And visual feedback color. So if I want the border of the slide or the fixation slide image subobject or slide text subobject to turn a different color, what color do I want it to be? By default, it stays at red, and that's exactly what I'm going to want it to do. But I can change it whatever color I want. So I'm just going to actually make this red. And I'm going to go ahead and compile just to make sure my syntax was correct. And it looks like there's an unknown function red. So to double check that, we'll just go ahead and put that in quotes. And there we go. So again, that's another way to use that generate button if you ever want to kind of troubleshoot what you're doing, especially in a package call like this where there's a lot of parameters. Now, the last one we have here is the visual feedback. The last one we have is the key. So if you remember my description of this, it says that it's going to simulate a button press. So it says an optional parameter to specify the key will be used as responsible subject to obtain fixation. If not specified, the one key will be used. I've also seen instances of people writing out space if they want the space bar to be pressed, or if, it all depends on how they want it to show up in their data file. That's entirely experiment dependent. I think the one is completely fine. So I'm going to click apply and OK here. And now I have to hop back to my fixation object, and I actually want to change my duration from 500 milliseconds back to 0. Now I want it 0 because the duration of it in that 500 millisecond wait that I'm adding is actually going to be handled entirely in the package call object. If I kept my duration at 500 milliseconds and didn't set that back to 0, what's going to happen is E prime is going to wait 500 milliseconds, then it's going to hit my TET wait for fixation, and then wait for me to fix it another 500 milliseconds, making this essentially at bare minimum 1,000 milliseconds long, which is less than ideal. So I want this at 0 milliseconds. Click Apply and OK, and I'll go ahead and check my border on this object, and it looks like my border color, where are we here? My border color is, or border is a width of 3, and my border color is white. So that's perfect, and then if I want to be red, it's going to basically look like this whenever the participant fixates on it. And it looks pretty cool. It's a nice visual feedback there, so I'm going to change this back to white. Click Apply and OK, and now we have our fixation set up. Alright, so the last thing we're going to add to the experiment is just going to be exactly, or telling ePrime exactly what we're writing to the gaze data file. Now this is going to be a little script intensive, and it's actually kind of a lot of script, so I have it pre-written as it was in one of our samples, and I'm just going to copy it into this and kind of walk you through it as I'm adding it to the experiment, because sitting here and watching me type it out is going to be a little boring. So I actually have it on my desktop here in my EET3, and then this one is going to be my user script. Now I'm just going to copy and paste it, and then like I said, I'll kind of explain it as I go. Alright, so if you take a look at the sample, I actually just pulled this straight from the sample. The first thing that I'm doing is I'm defining a user-defined type called user eye gaze data. So this is going to be the main bulk of the data that I'm going to add to my gaze data file and all of the variables that I'm going to be interested in. So trial ID, what trial am I on? What was the prime? What were both of the AOIs? So am I looking at a dog and a cat? Am I looking at a cow and a horse? Am I looking at a cat and a horse? What am I looking at here? AOI, specifically, which one is the which one are they looking at right now? AOI stimulus is going to be whichever AOI is correct. My correct response, my accuracy, and my RT are all going to be in relation to how quickly or slowly participants respond to stimulus. RT I already said. And current object is what are participants looking at right now. These don't have to be set in stone. They're absolutely not set in stone. All of my little definitions that I just gave aren't set at this point. Right now I'm just defining these variables called trial ID prime, and they're all string, and except for RT. RT's a long. But if I want, I can add anything I want here. So if I want to take a look at what the border color for my fixation was, for instance, I can say border color as string. And whatever you're interested in, you can put here too. Or I could put prime duration. And that's where I would add it first. I would add it as my type in my user gaze, or in my my user script here. So the next thing that's important is to look here. This is a subroutine that's created, or that we create, just called user write gaze data file. And this is what's going to actually be used to write information to the gaze data file that we open using this package call here. Now if you look here, this part of it from line 41 to line 45, these are all of the data points that are automatically included with every eye tracking experiment. They're nothing that you need to set up. It's nothing that you really need to do aside from just referencing them and saying, okay, I know these are going to be output to the data file. These include RT time, cursor X, cursor Y, which is just a location of the cursor on the screen. RT time is ePrime's timestamp of when this particular sample occurred. Timestamp microseconds, which is when the eye tracker said that this occurred. And then just different pieces of gaze information. And if you look here, it even includes pupil diameter here. The important thing to keep in mind too are these validity columns. So validity left eye, there's validity right eye. The purpose of these validity columns is just to let you know on a scale from 0 to 4 how good your eye tracking is. So how confident is ePrime that this is where your gaze was in the experiment. So those are also important to keep in mind as well. Now if you look here, we're also making other columns in ePrime. And these columns look very familiar, don't they? They're exactly what we're printing out here as the user gaze data. So we're just making sure that in our gaze data file there is a column for each of the pieces of data that we're interested in. And then this is append from standard data from EET, so we're just writing these things. If you remember, they look exactly like these column headers that we made here, and then we're printing out the gaze data file that we made as well, or all of the custom variables that we made as well. If you have any that are custom or you would like to add to this, keep in mind that you'll first have to add them here, then you'll have to add them here, and finally you'll add them here. Adding them up here at this very top just makes it something that ePrime is able to collect data for. Adding them here actually makes a column for it in your gaze data file, that's why it's important, and adding it here is telling ePrime, hey, we're going to be printing data underneath that column heading that we've made. Now the last bit of inline script that we need is actually going to happen just after our feedback object. Or you can put it just before. Either way, it doesn't necessarily matter. In the sample, it's just before, so I'm going to put it just before the feedback object. Oops, I'm actually put it after stop tracking. The important thing is that it comes after stop tracking, actually. And again, I just have this script in this text display, or text notepad. Now this looks a little big and intimidating, but it's actually pretty easy to handle here. First, we just have some standard if-then statements. What it's doing is just making sure that we're handling eye tracking data. It's making sure that the eye tracking is working correctly. This stuff up here isn't necessary, but it is really important. So it's making sure the eye tracker is open, making sure it's enabled, making sure there's actually a device there. It's setting a conditional exit and making sure you didn't actually exit out of the experiment. It's just some script to make sure that you're collecting good gaze data before you even get to this point. Now we just have some variable declarations here. And then what we're doing down here is, if you think back to that user script that we had, and I'll hop over here, we're actually giving all of these custom variables that we have, we're giving them a value now. So if I look at my inline one here, trial ID is just going to be the running.sample. So what is the actual ID? The prime is going to be set to the prime, which is an attribute in my trial list. Same for left image and right image. Now if you notice here, we set a couple of them to blank. So the AOI stimulus, and the current object are actually being set to blank strings, which means if we stop and print the data file out right now, nothing's going to be written to that. That's okay. We'll get to that because those are actually going to be filled in later. But if you look, our correct response, accuracy, and RT, we're setting them to the value of stimulus, correct response, stimulus accuracy, stimulus RT. Perfect. So now this is where we actually start filling in those. We start filling in all of those blank variables. So if you look here, we actually have a for next loop, and this is pretty much the next important part. Is what we're doing is we're taking all of the eye tracking data that was collected this round, and we're just incrementing through each and every level of them. And that's why this takes a little while. It's this for next loop, especially if you have a larger experiment. If you ever find that you have a pause in your experiment when it's writing out this data file, this is why it's pausing. So what it does is it's actually saying, okay, I'm incrementing through here. Now it's taking a look at the gaze data.RT time, and it's saying, am I in the stimulus object? So is the RT time greater than stimulus.onset time, which means, hey, participants looking at stimulus right now. And then it's doing something called the hit test method. Now, if you're familiar with ePrime 2, the way that you used to make buttons in ePrime 2 was using a hit test method, which would return the name of a sub-object that your mouse or cursor clicked on. It works identical for ePrime extensions for Tobii. It's returning the name of wherever your cursor X and cursor Y position was in your gaze data file. So if the string hit returned AOI1, which is the name of this AOI object here, it's going to say, hey, participants were looking at AOI1, and it's going to change the name of the stimulus to the name of the AOI1. Same with AOI2 and same with fixation. If I want to add more, for example, if I want a center AOI here that just says center, this is actually, if I take a look at its properties, this text display is going to be called text1. And what I would do here is I would just add a new case. So I would just change this, back it up a little bit, and my case in this instance is just going to be called text display 1. And my AOI is going to be text display 1. And my stimulus in this case is just going to be the word center. So now this is how it's going to appear in my gaze data file whenever they fixate on this little center text display object that I made for almost no reason, just to demonstrate this. But that's how you would start adding all of these areas of interest to your experiment, and how you write them out to your data file is you make them as slide text, slide images, slide movies, anything. They make them as slide sub-objects, and then in your gaze data file or in your save gaze data inline, like this, you just say, hey, if participants were looking at these things, then do this stuff. And that's exactly how you set it up. And then you just run this call here, just user write gaze data file, and that actually is what writes this data to the gaze data file. And then once it sees that it's all done, it's going to hop down to the Save Gaze Data Finish. It's going to release these references here just so they're not tying up your system memory, and then it's going to go on to the next trial. I am, however, going to rename this one quickly, just to Save Gaze Data File. Mostly because that's how it is in the sample, but also because I like the, the name to reflect the function. But I'm going to go ahead and save this quick, and then I'm going to compile this, make sure everything's all good, and everything is all good. And that's how you make a very simple eye tracking experiment in ePrime. This is going to be exactly what that extensions program, or that sample program, looks like. Whenever you install ePrime extensions for Tobii, this is the thing that you get. Now, for those of you using Pro Studio, and you want, if you want to send scene information from ePrime to Tobii Pro Studio, you can do that. Keep in mind, since Tobii seems to be moving away from Tobii Pro Studio and into Tobii Pro Lab, this functionality is no longer supported in Tobii Pro Lab, so I am going to go over it very quickly. But it is something that you can do with ePrime extensions for Tobii 3.0, so I do want to highlight it. Now what I'm going to do, if I want to send scene information, so let's say I want to take a look at my stimulus, and I want to say, everything that's about this stimulus object I want to send to Tobii Studio. I want to send a scene here, and I want Tobii Pro Studio to kind of take a look at this scene, and I want to take a look at where they've been looking across different scenes. To do that, what I'm going to do is I'm actually going to hop into my experiment object here, and I'm going to add a new package. Now my package is going to be called Clearview. Now Clearview is a part of Tobii. In the olden days, it actually used to be an entirely separate program that would handle these kinds of things. But it has since become just all Tobii Pro Studio, and in ePrime it kind of reflects how it used to be and is still labeled as Clearview, even though it does basically the same thing as TET. So what I'm going to do is add this Clearview package call. Keep in mind your number might look a little different. And I'm going to add another device in here, and this one's going to be called Clearview as well. Now Clearview, this is where I actually need to set the IP address instead of just doing the EPU02, which is not appropriate for here. What you'll need to do is you'll actually need to get the IP address of the computer that you have Tobii Studio on. If you've ever heard wind of a two-computer setup in ePrime for ePrime extensions for Tobii, this is exactly what we're talking about. You're going to need one computer running ePrime and running ePrime extensions for Tobii. You're going to need another computer running your Tobii Studio or Tobii Pro Studio. So that's going to be important, and this is going to be the IP address of that. So whatever your IP address happens to be, it's important to keep that there. Port number generally remains the same. If you notice, it is actually one more than our port number for our Tobii Eye Tracker. And then log file, we don't necessarily need that. So once you've set up your package and set up your device, what we'll need to do is we'll need to go into stimulus, because we want to actually send a scene start call to Tobii Studio to say, hey, this is where the scene that we're most interested in is starting. So I'm going to take, they're going to go into the properties page here, and instead of adding a package call object like we've done for everything else, we're going to actually add this through our task events feature. If you're unfamiliar with task events, it's a really useful feature. It allows you to time lock events or time lock different things with very specific timestamps in ePrime. And in this case, I'm going to make ePrime send a signal to Tobii saying, hey, my stimulus is on the screen, make sure that you have this, it's important. So I'm going to go to task events, I'm going to click add, and I want my stimulus.onset time, which is the time at which this object was drawn on the screen. Now I'm going to choose a task, and in this case it's going to be Clearview, because I'm going to be sending information from ePrime over to Clearview. Now my action here is I only have two, scene start, which is going to tell Tobii, hey, this is where I'm starting my scene. My source is going to be custom, I'm not going to send a timestamp, and my custom is just going to be the name of the scene. So in this case, it's just going to be called stimulus. And my data type will be string, that is the only option that I have. So I'm going to click apply and OK. And now I have a scene set up whenever I open Tobii Studio again, it's going to have a scene start that says, hey, this is where my stimulus started. Now in order to do these kind of scene analysis in Tobii Studio, it's important that you also have a scene stop that is identically named. So what I could do is I can have a scene stop at the offset time of my stimulus object, but it's important to keep in mind that my stimulus object has a pre-release set to same as duration. So if I do a scene stop in Tobii Studio on the .offset time of this object, it's going to look like the object was on screen for 1 millisecond, if that, sometimes even 0 milliseconds, and that's not ideal. So what I'll have to do is I'll have to actually either change the pre-release from same as duration to 0, or instead of doing my scene stop on the stimulus object, I'll do my scene stop on fixation, or on my feedback object here. Because basically what's happening is whenever stimulus leaves the screen, even though there's all this stuff in between, neither of these have a visual component, so they're not actually going to show up on the screen. The end of my stimulus object is the same thing as the beginning of my feedback object. So I'm going to go back into its properties, go to task events, and I'm going to add one for the onset time of my feedback. And this is where my stimulus scene is going to end, is on the onset time of feedback, and it's going to be a more accurate representation of how long this object was actually on the screen. So again, I'm going to add a Clearview package call. This one's going to be called scene stop this time instead of scene start. And again, it's important in Tobii Pro Studio that the name of the scene that you're sending, the name of the scene stop matches the scene start directly. So I'm going to put stimulus here. Data type will be string. Go ahead and click apply and OK. And now that's all I need. Now whenever I run this, not only am I going to eye track and I'll have my wait for fixation here, and I'll be saving AOI information to my experiment and to my gaze data file and be able to look at all of that later, but I'm also going to be sending really important scene information to Tobii Pro Studio for analysis in Tobii Pro Studio. So that's all you need to do to add all the eye tracking package calls to ePrime 3.0. If you guys have any questions at all about this, please feel free to submit a support ticket at support.pstnet.com. We are always happy to help. If you want a little bit more information as well, we do have some other YouTube videos on exactly this on our little YouTube channel there on pstnet.com, or just on pstnet on YouTube. As always, feel free to like and subscribe. That helps us keep doing what we're doing here. And if you have any recommendations for any future live streams, you have experiment, a package, a functionality that you want to see in ePrime, maybe something that you've been kind of working through in ePrime for a long time, and you think that it's really valuable information for other people, or heck, even valuable information for you, and you just want to watch me do it, by all means, let us know. Leave a comment in the comment section here. Send us an email. We're always happy to answer those. But that's all the content I have for today. I hope you guys had a great time. Thank you very much, and have a great day.